Hi, my name is Luciano Ferrari from LufSec, and welcome to our tutorial series. Today I would like to talk with you about how to do a firmware dump from an SPI flash memory. If you are into IoT security, IoT hacking, exploitation, this skill of firmware analysis is very handy. And here we will help you to start with firmware analysis, doing a firmware dump. The firmware I chose to use is the one that is found on the WRT node. The code is 25L12805F. It's from the WRT node. The WRT node board is kind of a dev board. It's a Linux distribution. It's very cheap and easy. To start, you're going to need to use a hardware that you have at your home. But before you open up devices that you may break it, like your Alexa, your Google Home, etc., or your Wi-Fi router, why not start working on something cheap like the WRT node, where if you break it, you lose maybe 20-30 bucks. So when we have a board like that, the first thing you're going to have to do is you have to find the firmware. Where is the firmware? There are many chips on the board, so which one is the firmware? So you get familiar with that, but if you are not, the best thing to do and how to start is really looking at the chips that are on the board and take note of the description, and then you go to Google and you try to understand what they are. When you find the firmware, then you have to go after a data sheet. You download the data sheet, and then with that you'll be able to identify all of the pinouts of that particular chip. So which pins of the chip do what are their purpose, so then you may start understanding how it works and how to interface with that. Okay, now I have identified the chip very well. Okay, so what to do now? Now we can try to read the firmware from the memory flash, but how to do that? We're gonna have to connect the pinouts somehow, and how you connect and how you do that, there are a few options you can do. One thing you can do is to unsolder the chip, the firmware chip, from the board, and then plug into specialized device like an EEPROM read and write device, or you can try to unsolder also, but instead of a device like that, you can put on a proto board, and then you use wires and jumpers to make the connections. Some people also like to use those hook cables, so they attach on each of the pins of the chip, and then the other end you plug on the other device that you need. I prefer using a SOC 8 clip. To me, I think that they are very easy and very handy. You just attach the SOC clip over your chip in parallel on the board, so you don't have to remove the chip from the board, which to me is very nice. So you don't have to unsolder and then solder it back. Less risk to break it and to burn it or doing something wrong. The other end of the wire that you did, you have to connect to a hardware tool. So what other tool you could use? You could use a hardware tool that will interact with your firmware, with the chip itself. And you need to understand what kind of interface your chip is. So that's why also it's very important to understand and read the data sheet. So I use the Atify badge, which is very handy. It's very efficient, and it can interface with with multiple different interfaces like SPI, like our case here, but it can also interface with UART, JTAG, I2C, GPIO, and etc. You could also use devices like Bus Pirate or even a Raspberry Pi. Okay, next, what is important to do is to make the proper connections. So you need to connect the cables from the chip to your Atify badge, for example, and how to make those connections, which pins go where. So to simplify the things for you, I had presented a table for you that you see on the screen. You're going to need to use the data sheet that you downloaded from the internet to understand which pins are what in the chip, and then use this reference table to understand how to plug into your interface to your Atify badge if you're using it. On the Atify badge itself, there is a table as well, so You could use that as a reference to understand what pinout to use, and depending on the device that you're using, if it's a bus bar, it will also you also find documentation on where to connect what. So after that, what you can do is power up your Actify badge. Yes, the Actify badge. Don't power up the WRT node. Don't power up the board that you are targeting that contains the firmware, because the power will come from your hardware tool that you're using. In this case, the Actify budget. Otherwise, you may overload the voltage on the pinouts, and you can burn it. Now, what you have to do is connect your Actify badge to your computer. Preferably Linux distribution. It could be on a virtual machine, or it could be a standalone device. It doesn't matter. And once you do that, make sure that the connections was properly. You could use, for example, LS USB to make sure that the badge is properly connected to the box. Now, for reading the firmware from the flash memory, you're gonna need a piece of software. There is a piece of software that we are going to use here that is a Python program, which is called SPI Flash Pi. You can download from the GitHub, and the links and references I'm providing here to my blog. Once you download it, go to the directory that you downloaded and issue the command from there. The command that you're going to be using is sudo python spi flash .py -r, which is for read the firmware. You could use -w if you want to write. Then the name of the file you want to create. In my case, I chose wrt-firmware. Then -s, which is for size. And then if you know the exact size of your firmware, you put it here. If not, you put a number that is large enough to read the entire firmware. Otherwise, you'll not read it entirely, and then you're gonna have problems. If everything went through, then you should have a file called wrt-firmware. Now, using beanwalk, extract the firmware so you can have access to the file system and make sure that the dump was done properly. You do beanwalk -e wrt-firmware, and it will reverse engineering the firmware. It will extract it, and then you just walk through the folders and files that were created, just like you see right here. So you can navigate, you can go to different folders, and you can see that the entire Linux file system is here. So this means that you made the firmware dump properly, and it's working. So congratulations. So that's it. If you like it, don't forget to subscribe to my channel and my blog. See you next time.